In topic 2.1, we're going to lay out some really important definitions that are going to pave the way forward for this class. And the first is this idea of average rate of change of a function over an interval. And the first really important thing for you to take away is that when we talk about average rates of change, if you see that vocabulary occur in this class, average rates of change, that is occurring over an interval. So you would be given two endpoints, and so let's just say arbitrarily we're talking about the interval a to b. So if you see that kind of vocabulary, you're looking at a closed interval, and the average rate of change is just going to look like the slope formula. And in fact, we visited this topic at the start of this class back in topic 1.1, where we said that the average rate of change was equal to the function value at b minus the function value of a over b minus a. And that kind of got back to our idea of change in y over change in x. But I really wanted you to think about it in terms of these function values over the x, or the independent variable values. Now the average rate of change, and if you want to go back and equate rates of change to the idea of slope, well, that average rate of change is the slope of what we called the secant line. That was between two endpoints of the interval. So imagine that I take a function like a parabola or something, and I say, hey, here's 2 points from a to b. We understand it maybe has some sort of different shape, but I can find that average rate of change just by simply finding the slope between those 2 points. So let's find the average rate of change. Of f of x equal to 2x squared minus 7x plus 4. And like I said, it has to occur over an interval. So we'll say over the interval 2 to 5. Well, I know just by looking at it, since I'm talking about average rates of change over this interval from 2 to 5, that the expression that will find that for me is going to be f of 5 minus f of 2 over 5 minus 2. So the next things that I'm going to need to know in order to evaluate this is I need to know what f of 5 is, and I need to know what f of 2 is. Well, if I just substitute those into the function, f of 2 is 2 times 2 squared minus 7 times 2 plus 4, and that comes out to be 4 and 8 minus 14, negative 6 plus 4 is negative 2. F of 5, meanwhile, is 2 times 5 squared minus 7 times 5 plus 4. And that comes out to be 25, which is 50, minus 35 gives me 15, and then add 4 is 19. So now I can substitute these values in. F of 5 we just said was 19. F of 2 was negative 2. And it's all over 5 minus 2, which is 3. This comes out to be 21 over 3, which is 7. So the rate of change, or the slope of the line that goes between the two endpoints of this interval on this given function here, would be a rate of change of 7. So the key takeaways here, average rates of change occur over an interval, and we find them essentially using our slope formula by knowing the values of the function at those two endpoints.